This lesson is on multiplying rational expressions. And we're going to multiply rational expressions in a very similar way to the way that you simplified fraction, or when you multiplied fractions. And that is, we want to simplify everything before we multiply. So remember, you can simplify any number on top of a multiplication problem with any number on bottom. So if we look here, we can simplify the 120 and 40. They're both divisible by 10. So we're going to simplify that to 12 over 14. 77 and 6 don't simplify, but we're going to look at the 6 and the 12. Since the 6 is on bottom and the 12 is on top, we can simplify that. They're both divisible by 6. So we have a 2 here. 14 and 77 are both divisible by 7, so we're going to do that. We're going to get a 2 down here and an 11 up here. And it's getting a little messy, so sometimes you might want to rewrite it. We have 2 times 11 over 2. We still have 2's that will cancel, and so when we multiply completely, we get 11. Now, when we have binomials or things like that, we want to factor first. I wanted to show you some examples of what they look like when they've already been factored. Both of these fractions, the numerators and denominators, have been factored, so we want to look for the things they have in common. Remember that you can only cancel a binomial with a binomial and a monomial with a monomial. So if you notice, we have an x minus 1 on top and an x minus 1 on the bottom, so those both cancel. Here we have a 10 on top and a 5 on the bottom, so that'll cancel, leaving us with a 2 here. Then what else cancels? We have the 2 and the 8. So the 2 cancels to a 1, and the 8 cancels to a 4. Then we have an x here and an x here. But since they're both on top, we can't simplify those. So we're going to go ahead and multiply. We have x times 1 times x on the top, which is x squared. And then this was a 1. 1 times 4 on the bottom is just 4. And that's going to be our final answer. Here's another example of when they've already been factored for you. You'll notice we have a p minus 4 on top, and we have a p minus 4 in 2 different places on the bottom. That p minus 4 only cancels with one of the p minus 4's. And then we have a p plus 6, but we don't have a p plus 6 on the bottom. So that is all we can factor. Even though there's all that stuff, that's the only thing that simplifies. So we have p plus 6 over p minus 4 times p minus 2. Okay, in this example, we haven't factored yet. So we know our monomials we're going to leave alone, but we have x squared minus 81, and that's a difference of perfect squares. So that factors to x plus 9 and x minus 9. And then we're going to look for things that cancel. So we have an x plus 9 on the top. That's going to cancel with our x plus 9 on the bottom. Our 3 and our x are our only monomials, and they don't simplify. So on our top, we have x times 1 is x. And on the bottom, we have x minus 9 times 3. So I'm going to write that 3 out in front, just because that's normally how we see it written. And that's our final answer, x over 3 times x minus 9. Then they get a little bit messier kind of as you go on through the worksheet, but we just factor everything. 45x squared is a monomial, so we leave it alone. X minus 9 is a binomial, so we look for a common factor, which there isn't, and we look to see if it's a difference of perfect squares. The 9 is a perfect square, but the x is not, so we're just going to put parentheses around it and leave it alone. Then we factor x squared minus 5x minus 36. We have an x and an x. It's a minus 36, so we know our signs need to be different, plus and minus. And then we need factors of 36 that add to give us negative 5. So let's see. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9. There we go. Positive 4 and negative 9. And then on the bottom here we have a binomial. So we want to look for those common factors, and we have, it looks like a 3x squared. And that leaves us with x plus 4. Go ahead and scratch those out since I factored them. Now I want to go through and start looking for common factors. We have an x plus 4 on top and an x plus 4 on bottom, an x minus 9 on top and an x minus 9 on bottom. Now we have these two monomials. I'm going to rewrite it so I can see it a little better. 45x squared over 3x squared. The x squareds cancel. 3 goes into 45 15 times. So our final answer is 15. That one started out really ugly and gave us kind of a nice little answer there. Okay, we have one more. This is the last one. We're going to factor out, let's see, we have a common factor on top, so we have 2 times x minus 1. And on the bottom we have 1 minus x. Now it looks like that's all we can do because our x minus 1 and 1 minus x are not identical. But I want to show you what happens. On the bottom, I want to factor out a negative 1. And if we factor out a negative 1, our 1 becomes negative and our x becomes positive, which is the same as writing negative 1 times x minus 1. So what you see here is that x minus 1 and 1 minus x are opposites. Now we can cancel that x minus 1 and we get negative 2. Now that was a kind of quick example of that one, but we'll talk about more about those opposites in class.